Alright, so here's my working to find the order with respect to A for the equation A yields B. So I go on the simulation and I need to collect some data for how A affects the rate. And to make life easy for yourself, I would do concentrations where one is double the other one. Because the kind of thing you're looking for here, right? You have three options, really, for common orders of reaction and what effect they will have on the rate. If it's zero order, then doubling the concentration has no effect. Zero. If it's first order, doubling the concentration will double the rate. It has the exact same effect. If you have second order, then whatever you do to the concentration happens twice to the rate. It's double the effect. That's why it's called second order. So the rate would be times 2 twice, or times 4. Okay. So when I plug these numbers into the simulation, my first trial I got 4.18 times 10 to the minus 3 molar per second. And my second trial, I got 8.35 times 10 to the minus 3. And automatically I can see it's doubled. Okay, it hasn't quadrupled and it hasn't done nothing. It's a tiny bit off. It would be 8.36, but I can certainly say that that's double for experimental data. I would be really pleased if I did an actual experiment and I got that close. So this definitely looks like this option here, first order. That's my first answer. A is first order. Then we need to write the rate law. The rate law is of the form rate equals K times whatever your reactants are. In our case, it's A, to the power of the order. If the order is 1, we just leave it off. Okay, solving for K. First rearrange, so K equals rate divided by A. Then sub in some numbers. It doesn't matter which numbers you pick. If the equation's correct, it should work. I'm going to pick the second lot just because it has a 1 in it, so I know my math will be easy. So 8.35 times 10 to the minus 3 divided by 1, which is simply 8.35 times 10 to the minus 3. To work out the units, start with the same expression for K and just plug the units in. So molar per second divided by molar. The molarities will cancel and you'll be left with seconds to the minus 1. So for this one, K is 8.35 times 10 to the minus 3 seconds to the minus 1. And you're all done.